In this video, we will discuss the pros and cons of adopting different solutions for sustainable community electricity access. We'll start with solar photovoltaics, which is also known as solar PV. Solar panels are made of layers of semiconducting materials such as silicon. Particles of light from the sun interact with the layers to create an electrical field, which generates a flow of current. Falling costs have generated much optimism about solar in recent years. The International Renewable Energy Agency found that between 2010 and 2019, the cost of panels dropped by 82%. Other advantages of solar PV are that maintenance requirements are low and that systems are modular, meaning that more panels can be added to an array as demand grows. On the other hand, solar systems are heavily weather and geography dependent. A solar panel on the equator will have a higher output than one located in the Arctic, and even that won't work as well on a cloudy day. Another challenge is the time lag between peak solar output, which occurs in the middle of the day, and peak domestic demand, which is in the evening. Navigating this offset requires expensive batteries to be integrated into the system. Finally, there are increasing concerns about the environmental impacts of the hardware. Manufacturing solar panels requires a lot of energy, usually from fossil fuels, and hazardous chemical inputs. At the other end of the scale, processes for recycling solar panels are immature. Therefore, if solar panels are underutilized and improperly disposed of, then they can do more environmental harm than good. We will now move on to discuss small wind turbines. This technology works by using wind to turn the propeller-like blades of a turbine around a rotor. This subsequently rotates a generator, producing electricity. Wind energy is one of the oldest energy sources exploited by humans and is the fastest growing mode of electricity production across the planet. Small wind turbines are extremely efficient and relatively cheap to maintain, although only skilled technicians can do so. They can generate electricity at all hours of the day, as there are no time constraints on when the wind blows. Equally, the wind cannot blow at any time. This unpredictability and intermittency are significant disadvantages of small wind turbines. Another is the aesthetics of the turbines. Not everyone thinks they are pretty. Finally, it is important to note that this technology can only be used in specific sites with high wind potential. Even small-scale turbines cannot be located in urban environments because of the turbulent airflow that occurs in built-up areas. Next, we have microhydro plants. These work in the same way as wind, except that the fluid rotating the turbine blades is water rather than air. Water is diverted from a river at a point with high gravitational potential, such as a waterfall. It is channeled downhill to build up speed before being used to drive a turbine and a generator. It is then returned to the original river. Unlike hydroelectric plants, the installations have no dams or reservoirs. Electricity generated by microhydro is far more reliable than that from wind or solar. It is not dependent on the weather or the time of day. Microhydro systems have a low environmental impact and can be extremely cost-effective due to their long lifespans. They can last for up to 50 years. However, they are not an option for all communities as they require specific site conditions. There must be an accessible river with a sufficiently powerful flow within a short distance. The efficiency of the turbine is very sensitive to the water flow, so seasonal fluctuations in the river can have a large detrimental impact on power output. Diesel is a fossil fuel, not a renewable energy source, but is included here because diesel generators are often used in combination with the other renewable technologies we have mentioned. This combination of a diesel engine and an electric generator is known as a diesel generator set or genset. Diesel gensets can be used as primary sources of electricity, to complement renewables, or as a backup for mains power grids in the case of blackouts. The main advantage of diesel gensets is that they provide on-demand electricity. Because diesel is primarily used as an automotive fuel, it is widely available and cheap, even in remote areas, especially in countries with subsidies in place. However, the resulting carbon emissions and air pollution are bad for the environment and bad for people's health, and the engine and generator combination is extremely noisy. So far, we have discussed electricity generation through solar PV, small wind, microhydro, and diesel gensets. Each of these technologies can be used as standalone systems, meaning they provide unconnected autonomous electricity supply for individual households or businesses, or they can be assembled into mini-grids. Mini-grids resemble miniature versions of the electrical energy infrastructure that can be found in high-income countries and consist of power generation, distribution, and storage elements to provide electricity to whole communities. Well-designed mini-grids often incorporate multiple electricity generation technologies to counteract the disadvantages of relying on a single source. They can provide electricity that is of as high a quality as the national grid, but they require considerable investment to build.